Good evening, everyone. I am Siva Sabri and I am delighted to welcome you all to this workshop on Azure Cloud Networking, led by our amazing speaker Krishna, organized by PEP Cloud Computing and DevOps Center. It is always a pleasure to see such enthusiastic learners coming together to explore the ever evolving cloud world of cloud technologies. And this workshop will provide you a strong understanding of essential Azure networking concepts and hands on knowledge. Without any further delay, let's dive into the session. Over to you, Krishna.
Yeah, thanks for the wonderful introduction, Sabri. So, yeah, good evening, everyone. I'm Krishna, and I focus on cloud and cloud network, and particularly security. So, when it comes to cloud providers, I my expertise is more for particularly Azure, and also I've been focusing on some networks. But yeah, my major focus towards Azure. Okay. So today's topic, I want to teach you all about the networking part in Azure. Okay. So just a minute, let me share my screen. I have my screen was visible. S- Yeah. So yeah, networking in Azure. Networking in Azure. Okay. Uh, I hope everyone knows about what is a computer network, right? It's okay if you don't know. Let me repeat. So computer network is nothing but so guys. So computer network comprises of all your devices. That will be a mobile phone. I mean mobile. Yeah, smartphones or your PCs, printers, etc. Okay, interconnected to each other in order to establish the communication between each device. Okay, so it doesn't stop with your mobile. It doesn't stop with all these devices. In order to establish the communication, there are some intermediary devices that comes into play, like you have routers, switches, and hubs, etc. Okay, so these devices are used by the IT industry before the what do we say before the introduction of cloud. Okay, but today's world has changed. Okay, with the introduction of the virtual network in cloud, we as the IT industry or your IT administrator, you don't need to manage the physical infrastructure of the network. Okay. So before diving into the virtual network concept, I want to differentiate between the traditional computer network and the cloud virtual network. Okay. So in the traditional computer network, we had to maintain the physical infrastructure. So this physical infrastructure based on the physical routers, switches, and also the cabling part. Okay. And the management concern, it requires manual configuration and maintenance of the hardware. So whenever needed to increase our resources, it again becomes a hefty process because of the pricing and also again the management part. Okay, and it is not flexible enough for all the IT industry. Like small companies can't afford to do all such things, right? But after the introduction of virtual cloud, we saw a very drastic change. Okay, so all the networks are entirely software defined, and these virtual network provisions are done by the our top cloud providers like Azure, and also the rest of the providers like AWS and GCP, etc. And regarding the management concern, we have API calls, which is actually managed by the cloud provider side. And also regarding scalability and cost, we go in the pay-as-you-go pricing, means you pay only for what you use or how much you utilize the virtual network. And scalability concern, you can increase the resource as much in accordance to your necessity. Okay. So this is the benefit of virtual network in cloud. Okay. So as you see, Microsoft Azure's virtual network provides you the security and scalability, means you can increase or decrease your resources as per your demand, and worldwide access, hybrid capability, meaning you can integrate with your on-prem or also with other cloud provider, and also at last the flexibility. Okay, so that brings us to the Azure Global Infrastructure, which comprises of regions and availability zones. I have missed something called as edge locations. Let's look at it. Okay. So regions. So Azure regions are nothing but the geographically distinct locations. Okay. Where Azure data centers are deployed. Okay. So these data centers are essential. They are the backbone of Azure's cloud. Okay. Wait a minute. Yeah, okay, this is good. So as you see, every region of Azure comprises of availability zone. Okay, these availability zones are nothing but physically separate data centers within an Azure region. Okay, and so far we have around. Excuse me. Yeah. So regarding the downtime and uptime, Azure guarantees 99.99% SLA for the VMs when deployed across these zones. Okay, and it also supports zone redundant services like Azure SQL database and AKS, Azure Kubernetes Service, etc. Okay, so what are the purposes? What's the purpose behind the regions and the availability zones? It's nothing but in order to provide resilience and high availability by isolating the failures and also the network. Okay, like for example, you don't want your what do you say? Yeah, another department, like you don't want your finance department to access any resources in the in the development department, right? So all those restrictions can also be done in the network level too. And for such purposes, Azure regions and availability zones play an important role. I hope it is understood by everyone. So also I have left something called as edge locations. Okay, edge locations are nothing but they are the points of presence for delivering the content and services to end users with minimal latency. Okay, so nothing but if your customer lies within the within some range of within some distance between the points of presence, meaning the edge locations, you can then configure in such a way that your content gets shared to that user living nearest to the edge location, right? So this is a big advantage, and it has been essential to all the big companies, who companies and also to the customers who live in remote areas. So this is about availability zones, Azure regions, etc. And if you have any doubts, please ask right now. So far, so good, I guess. I guess, yeah. Let's go to the next one. So, yeah, these are the regions, Azure regions, and within these Azure regions, there are yeah, n number of availability zones. Okay. So networking regarding, Azure networking services. So we have content delivery network and express route and Azure DNS, virtual network, traffic manager for managing all the load balancers. Again, we have load balancer, VPN gateway, and also for application gateway, DDoS protection to prevent the DDoS attacks, network watcher for monitoring the network metrics, and firewall to protect your applications, virtual WAN, and also Azure frontier service, which is another content delivery network service. So Azure networking thing, like what are the properties that satisfy me? So virtual network again helps me to deploy my own network, right? You don't want your organization to rely on a public network. Okay, so if your organization relies on a public network and deploy everything in the public, it is highly vulnerable to attacks by the adversaries or hackers. Okay, so in order to mitigate or in order to secure their resources, each and every organization brings their own network, deploy their own network, by setting up their virtual network and subnets, specifying the IP addresses and public IP address. Let's look into all the stuff later. So segment the subnets and security groups. Again, I have previously said about the isolation part, right, regarding the resources and regions. This is where you isolate your resources and control the traffic with user-defined routes. Okay, so like HTTP requests and HTTPS requests, all these requests must be directed to the particular virtual machine in order to be available for the end users who use your product. Okay, so for the sake of that, you have user-defined routes in such a way to control the traffic flow. Okay, and network security groups. So network security groups are nothing but it involves the mentioning of your inbound and outbound rules. Okay, inbound and outbound routes in order to allow and restrict the access to particular network services. Okay, so this is what about the network security groups are. And backend access, it involves a VPN gateways, point-to-site VPN, site-to-site VPN, express route, and followed by that virtual network peering. So VPN gateways, again, they are another type of isolating servers. For example, let's say we have a point-to-site VPN. If you are an employee working in an organization A and you are living in a remote area, like your organization lies in New York, but you work in somewhere at India. Okay, you don't have the access to you don't have the access to the organization A's network via the public internet. Okay, so because that would again is an unencrypted network connection, which would be intercepted by the hackers or any other. It's in general, it's not safe to do so. Okay, so in order to have a safe and secure network with the uh, organization A in the New York, you will be provided a VPN credential. Okay, so for such cases, point-to-site VPN comes into play. Okay, point-to-site VPN comes into play. And regarding site-to-site VPN, it is about like if your organization A lies in New York and its child organization lies in India, okay, all the employees in the organization B will be able to access the ones in the organization A with the help of the site-to-site VPN. It is similar to point-to-site VPN, but point-to-site VPN allows an individual computer, but site-to-site VPN allows a large number of computers to access each other. Okay, so this is what is our point to say. Let's get into detail later. And express route. So express route, you can define the routes, and you know previously we have seen about. Excuse me, guys. Yeah, sorry. So express route again, it provides an isolation network, meaning a private connections between the Microsoft data center and infrastructure. Okay, to your on-premises network. Okay, so basically it provides a connection between the Microsoft data centers, meaning the availability zones, and the on-premises devices. Okay, so virtual network peering. So this is about establishing the connection between two or more virtual networks. Okay, so why do we need virtual network peering? Let's see in the later slides. So front-end access, we have load balancing solutions and public and private IPs, Azure DNS, DDoS protection, direct VM access. So all these services are essential for the client side to access your product. Okay. So these are the Azure networking components which are put together. So as you see, you have a on-premises data center and the internet. Okay, for the on-premises data center to access these, we have to establish a VPN gateway, meaning this is not exposed to the internet. So without being exposed to the internet, it uh, you know it has to connect directly to the this subnet, okay, with the help of VPN gateway, and then goes to the internal load balance and all stuff. So as you see here, this is the internet public and next external load balancer comes with the public IP, which again, you know, you can deploy a VMs or attached with the NICs here, thus being exposed to the internet. For this is essential when you have to deploy websites, or when you have to deploy websites, etc. So on-premises data center, again, for establishing a private connection with the help of VPN gateway, and seems social network peering is not available, but yeah, fine. So and so. So yeah, the NSG groups. So these NSGs, allow and deny the traffic based on the what type of ports they want to access. Looks at the source IP and also the destination IP, etc. And as a whole, this is the Azure Virtual Network and the region, etc. I hope it is clear to everyone. If I'm going at a fast pace, please stop me and raise questions. Let me wait for 2 minutes. And yeah, if you want to ask questions, just unmute yourself and ask. I can't see the messages. So that's a yes. I guess everyone is clear with the concepts. Let me move to the next slide. So Azure Virtual Networks. Okay, this forms the essential part of your virtual cloud. Azure Virtual Network is created in a virtualized environment. Okay, virtualized environment, allowing your like the VMs that I deploy and like the app servers and other functions which I use to communicate with each other and also with outside world. I think, but the internet. Okay, basically, if I want to expose my virtual machine or whatever app that I deploy using other servers, I need a virtual network. Okay, and it doesn't stop with that. Whether I have to decide whether I want to expose it into the internet or to the public organization which I work. I mean, sorry, private organization um, within that I work. Okay, so Azure Virtual Network again replicates the functions of a traditional physical network, but within the confines of a cloud infrastructure. Okay, so as you see, it actually imitates the physical network. Okay, like the routers, subnet. I mean, sorry, yeah, routers, switches, hubs, etc. It imitates the network, but it again, as I said earlier, it is enforced by the software type of things. Okay, like the API calls, all other stuff. So Azure Virtual Networks. So okay, these are the key aspects. Okay, every virtual network provides an isolation. Okay, they can operate independently by default. Okay, and subnets can be, I mean, sorry, VNets can be again divided into subnets. So as you see, okay, this is a subnet. This is one subnet, and this is another subnet. So we have a total of three subnets. Okay, and these three subnets are deployed into the same virtual network. I mean, sorry, divided into the same virtual network. Okay, so virtual network again gets public IP. I mean, we assign a different IP, and subnets we define another IP in such a way that both these IP address spaces do not overlap with each other. Okay, let's look at why they shouldn't overlap. Okay, and before that, we have another aspect called as IP addressing. So VNets can use private IPs, okay, and we can configure our own IP address ranges. So regarding network security, they support network security groups, which I mentioned earlier, where you define inbound and outbound rules, right, to allow and deny the traffic. incoming and outgoing traffic. So load balancing, it's like, you know, handling the number of requests and distributing to the servers accordingly. Yeah, accordingly. And integration with other cloud services too. So it means it doesn't stop with deploying the VMs, but also comes up with using app services. Okay, and whatever service that requires virtual networks. So these are the key aspects. So yeah, I have talked set about IP address ranges and subnets, right? So one or more non-overlapping address spaces are defined. Okay. So as you see, this is the CI. We call this as a CIDR notation. Okay. So we define the CIDR notation for the first virtual network, and then to define the subnets, we define a set of CIDR ranges in such a way that they don't overlap. So if, as you see, 10.0.0.0/16 is there. Okay. So 16 is the CID notation, which means we are using 65,536 addresses. Okay, crazy, right? So again, we looking into these subnets 10.0.1/24 means we are using 256 range of addresses only. So how come they don't overlap again? So as you see, IP address assigning us kind of contiguous thing. Okay, like as you see here, like the CIDR notation of virtual network, it starts with 10.0.0 and 10.0.01 and 10.0.02, etc. Okay, so in order not to overlap with the range, we define 10.0.1.0 and 10.0.2.0, etc. So what if what if I mention the subnet as 10.0.0.1/16? So that would result in something called as clashing of the IP addresses. System voice. Wait a minute. Okay. So yeah, if I define the subnet of apps as 10.0.1/24 and subnet data as 10.0.0.2/24, it would not work properly because these definitions becomes invalid. Okay. Although I define 256 IP addresses, it again must log with the log size of the starting addresses. Okay. So why again miscellaneous subnets fail? If I attempt to define a subnet starting at 10.0.1, like the subnet apps and data, okay, they both will overlap with the same block of addresses because 24 always encompasses two physics contiguous addresses, okay, at a valid block boundary. Okay. So this issue will result in the routing protocols and all of that stuff. So this is why you should carefully mention the address spaces when defining it for the virtual network and also for the subnets. Okay. So this is about address spaces and subnets. And before moving into the next slide, I want someone to raise a question, like if you have any doubts. I'm going too fast. Yeah. Okay. Fine. Oh. So that was about the virtual networks and address space and subnet definition, etc. Okay. So network segmentation. Next. This is something that we have seen so far, like a revision topic. So once you define a subscription, it's another type of isolation part. Like you can have multiple subscriptions in your tenant. Okay. So virtual network. Yeah, every virtual network is deployed independently. If you deploy, if VMA belongs to a virtual network one, it cannot ping or access anything in the virtual network two unless you define the virtual network peering concept. Okay, so let's look into that too. And network security groups, it to what do we say? Yeah, allow and deny the incoming and outgoing traffic, etc. And web application firewall, it's nothing but your traditional path, like prevents your web application from your the vulnerable attacks like SQL injection and what do we have? Cross scripting, etc. Okay, and Azure firewall in general. So web application firewall is for the web applications, and Azure firewall in general it is for the what do we say? Yeah, virtual machines. Okay, in general, Azure Firewall is used for the protection of virtual machines. And then we have your bring your own DNS property. So this is about specifying the DNS servers at the virtual network level. Okay, so I hope everyone is aware of DNS, right? So whenever you launch a website, you can't directly access it via the IP address. Okay, it's not a good thing to be honest. Okay, like when it goes into production, your website should have a unique namespace, like sorry, unique name, like for example, conteso.com, like yeah, conteso.com. Okay, so but conteso.com points to another IP address. Okay, and using that IP address, customers shouldn't be accessing your product, which isn't good. Okay, which isn't safe too. So yeah, we buy domains like conteso.com or whatever meow.com, etc. So this is what is DNS about. Okay, it basically acts as a address for your IP addresses. Simple. And yeah, coming back to bring your own DNS session, specify the DNS servers at the virtual network level and host. So every DNS server is hosted in Azure Virtual Machine. Okay, so these DNS servers will point out or will route you to the will route the customer's traffic or the request to the website where your sorry to the VM where your website is deployed. Okay, and also this could be integrated with your on-premises things with the help of hybrid connection property. So virtual machines are assigned specific DNS at the port. Okay, so if you look into if we have tried using Azure portal, I mean, and launched a virtual machine, you always come across with some unique, DNS name, like with the what do we say, with the region specified there. Okay, just try deploying a VM, you can understand it. Or let's yeah. So if a DNS is added at a virtual machine is running, a reboot is required for the assignment. Okay, like initially some would uncheck the DNS option, but later then they check like they later they want to enable the DNS option. So if they are doing such thing, they have to reboot their virtual machine such that the DNS gets assigned to that virtual machine again. So public IP address, we want our web applications to be publicly accessible. Okay, so for the sake of doing that, uh, every virtual machine gets assigned a public IP address. Okay, so public IP address can either be assigned directly to the network interface, meaning the network interface of the virtual machine, or to the load balancer. Okay, so if the virtual machine has what do we say, uh, you know, like if your web application is deployed on multiple servers, and if that web application receives multiple requests, then load balancer comes into play. Okay, so the load balancer comes into play and helps the customers to access your website easily. Thus there will be no restrictions in the or any headache related thing regarding your what do we say, availability of your web application to all the customers across the globe. Okay, so this is about the load balancer. Yeah. So let's get back to the public IP address again. So public IP address also supports static or dynamic assignment. Okay, so most probably we prefer a static assignment of our the VM virtual machine or whatever service that you are trying to assign the public address. Okay, dynamic assignment, well, it's kind of a dynamic thing, I don't prefer dynamic assignment, to be honest. But yeah, we look for a static, and yeah, so static IP addresses work in such a way that they don't change even after the reboot of a virtual machine. And optionally, look in the word, carefully look at the word. Optionally, they support specifying a DNS label, meaning the domain name, etc. And also we can specify the timeout too. Okay, so timeout is nothing but if we are facing enough downtime or can't access it for a limited amount of time or specified amount of time, it automatically defaults to the error page, right? So then, yeah, so Azure provides four static IP addresses as free. Okay, static IP addresses generally don't come free, so please, if you're using Azure, if you're an Azure user, carefully use the static IPs. And private IP assignment rules. So IPs are allocated based on the order of provisioning of the network interface cards. This means that if I have NIC1, NIC2, etc., okay, and if I have subnet 10.0.1.0/24, meaning I have 256 IP addresses starting from 10.0.1.0, okay, my first NIC would be assigned 10.0.1.1, and then followed by that the NIC, I mean second NIC would be assigned 10.0.1.2. Okay, so like yeah, 1, 2, 3, 4, 5, they would be assigned like that. Okay, so better, recommendation is use static private IP addresses to retain the IP regardless of the order. So you don't care about the order, okay, but use static private IP addresses. So Azure load balancing solutions. Stay voice. So Azure load balancing solutions. Regarding that, we have so Azure load balancer works on the layer 4, which is an application layer, I guess. If you look into detail of the OSL layer, you will find out. Okay, and it supports both external or internal load balancing. So external load balancing, it is good when you have a web application hosted on a VM, okay, such that it is exposed to the internet and also publicly accessible by the what do we call? Yeah, the customers. Okay, internal load balancing. So this is about also the back end. Okay, so if you're going for a 3-tier or 2-tier architecture of the websites, you would prefer using both external load balancing and internal load balancing. So external load balancing would be helpful if you have a web application that receives like HTTP or HTTPS requests, right? So what about internal load balancing? So internal load balancing helps if you have a database at the backend, okay, but it shouldn't be publicly accessible, and also at the same time, it should be accessible to the website alone in such a way that the website can store its, the details of the customer, whoever orders or whatever they store, the passwords, etc., to be stored in the database. Okay, so for such cases, we use internal load balancing. We use internal load balancing. Yeah. So for the regarding load balancer, we have TCP and UDP protocols supporting it, and also help like, which means that the automatic checking whether the load balancer is fine or not takes place for a specified amount of time. Yeah. So this is about the load balancing solution. So again, this is about the network security groups. We have previously seen about this, but yeah, again, so network security groups, they enable network segmentation and TMZ, nothing but demilitarized zone scenarios. Okay, so demilitarized zone scenarios, like demilitarized zone, they exist in order to trick the hackers or any adversaries who are trying to harm your whatever resource that you have deployed in your virtual network. Okay, basically honeypots. You can call them as an equal to honeypots, but yeah. So as I said earlier, NSC contains a set of AC rules, meaning access control list rules that can allow or deny network traffic to the virtual machines in a virtual network. Okay, and we can also restrict the traffic from or to external or internal resources. As it like yeah, I said about the website and all that stuff, right? In order to do such things, we can specify them in the network security groups, but also we show that network NSG's effects takes place within the region where it was created. Okay, so we can manage them using Azure portal or Azure template or the command line, Azure CLI or PowerShell command lines, etc. So Azure default network routing. So if you have, I mean, this is about you know just you deploy a virtual network and VMs in that and how it works. Okay, so traffic automatically flows between the VMs in different subnets and even address spaces. Okay, as you see, Azure has built-in default actually not nodes routes. Okay, Azure has built-in default routes. Okay, so it enables routing within the subnet and also from a subnet to the another subnet in the same virtual network. If there are two or more subnets, and if you deploy the VMs in such a way with their NS3s defined, it can communicate. That means the VM1 in the subnet A can communicate with the VM in the subnet B. Okay, so you can define all such things, and also you can expose your VMs to the internet again for the sake of accessing your web application if deployed in the virtual machines, and virtual network to virtual network using a VPN gateway. Okay, and also virtual network to the your on premises. Again, so on premises involves your hardware and physical infrastructure, right? So for such things, you can use a VPN gateway, and the- sorry guys, just a small introduction. Yeah, so where was I? Yeah, so virtual network to virtual network, meaning it can establish communication between two virtual networks using the VPN gateway and on premises. Yeah, so on premises means your physical infrastructure. Okay, establish a communication between the virtual network and also your on premises infrastructure using the VPN gateway. So this is VNet peering. Okay, so this is about establishing the communication between two virtual networks, or if more than two virtual networks present, you can also establish between them. Okay, but the thing is, you should look whether these virtual networks exist in the same region or on the different region. It is actually possible if you have a virtual network in one region and also in the other region, but that is a hefty process. Okay, so we have. As you see, Azure utilizes just a minute. Yeah, okay. So Azure utilizes the means VNet peering utilizes the Azure backbone network, and it appears as one network for connectivity, but can be managed as separate processors. Okay. So as you see, you can enable your peerings if you have deployed your virtual network. Okay. Virtual machines will experience the same throughput for the peer-peer VNet as they are not on the same VNet. Okay. So this is about the ingress and egress stuff. That is some kind of advanced stuff which we will later look into it. So why should we have multiple VNets? Having multiple VNets in your subscription will enable for a good, not for good, like you can observe, or you can, yeah, observe is a better word actually. So you can actually note down the building for each separate resources, okay, and also every minute can be assigned a administrator. Like, yeah, in case you all get my point, right? Every VNet gets a separate admin and also a separate building option. Okay. In such a way, we have a clear view of what we are actually doing and where we where we can optimize the cost, etc. So these occurs in most enterprise related agreements. But a weak VNet cannot span subscriptions. Okay, subscription can have VNet, but a VNet cannot span subscriptions. Yeah. So final thing. So regarding VNet peering, there are a lot of advantages, but it comes with some limitations, right? So the virtual network peering is sometimes between the two virtual networks, meaning the A and B virtual network can talk to each other, and B and C can talk to each other, but there is never an option where where A virtual network can communicate with the C virtual network. Okay, so this is a big limitation. I consider this as a big limitation, to be honest. And VNet address spaces cannot overlap. Okay, so as you see, I have previously mentioned where you should mention the CID and address space, and in such a way that the subnets shouldn't overlap with each other, right? So again, here VNet address spaces should not overlap with each other. Okay, like the same thing, but that is for subnets. But this is about when establishing virtual network peering between the between the virtual networks. Okay, so every virtual network must be linked to the same Azure AD internet, and internal virtual network traffic is not encrypted. And also, we have seen about the bring your own DNS, right? So we should implement that feature too here. And also, as you see, default limit of 10 peerings per VNet. Okay, so maximum of 50 communications can be established. So this is about the virtual network peering. And so far, if anybody has doubts, please raise. I guess no one has. So what is Azure Express Route? Okay, I guess this is the last one. Or not. So as you see, virtual network and on-premises network. Okay, your on-premises network and virtual network should communicate with each other. In order to establish that, Azure Express Route plays an important role. Okay, so yeah, every organization like present. I'm speaking of the present. Okay, so they want to utilize their on-premises infrastructure to the fullest. Also, on the other hand, they also want to use the virtual network. They also want to utilize the power of virtual network. Okay, so in order to do that, like in order to integrate, in order to establish a communication, they said they can use express route to extend the communication between the on-premises and also the virtual network deployed in Azure cloud. Okay, so this is a cool, service I have come across. So it involves a layer 3 connectivity between the on-premises and MS cloud, Azure cloud. Okay, and support for Sky businesses, establishes dynamic routing and also connection uptime. Doesn't means It means that your connection can live for a long time. Okay. So this is the example, your customer network and with the help of partner edge. it establishes a connection using a primary and secondary connection. I mean, express route does the things. Okay. And by establishing such private connection, you have access to Microsoft resources like OneNote and sorry, not OneNote, it is yeah, whatever Word, Office 365, and other virtual services, and also the ones like the virtual networks where you have deployed your virtual machines and so other services, etc. Okay. So other features of Express Route includes connectivity to MS Cloud services, meaning MS Office 365, MS Dynamics 365, apart from the services like PMs and Azure and Cosmos DB, etc. Okay. Uh, as you see, these are the other services, and these are the services that are present in Azure. I hope you get the point. Okay. And enables global connectivity by establishing the connection between on-premises and also the virtual network. Dynamic routing, so it Express Route uses BGP protocol. Okay, so it's something called as border gateway protocol. So with the help of this protocol, it exchanges the route between on-premises networks and also the resources running in Azure. Okay, so BGP protocol is nothing but it is a set of standard rules that governs how the data is routed across the on-premises and the resources that you have deployed in Azure. Okay, so built-in redundancy, it uses redundant devices to ensure connection that are well established with MS and Microsoft. So that brings us to traffic manager next. So we all know management meaning you know overlooking into I mean sorry you know, managing all the things like from as a whole administrating all the services that you have deployed in your tenant, etc. Okay, but traffic manager specifically helps you to you know access a DNS based traffic load balancer. Okay, and also allows you to distribute the traffic to your public facing applications across the global Azure regions. Okay, so it uses actually it needs a DNS endpoint, and with the help of that, it provides your public endpoints with a high availability and quick responsiveness. Okay, say for example, you have a e-commerce website, right? So for that e-commerce website, you define some DNS servers. Sorry. Yeah. So for public facing applications, meaning like for example your e-commerce website, etc. Okay. So for in order to expose your e-commerce website and to be publicly available, you can go for traffic manager load balancer. Okay. So this traffic load balancer, traffic manager uses your DNS name of your website and in such a way that your public endpoints will get exposed with high availability and with quick responsiveness. Okay, this is about traffic manager as simple as that. So as you see, I define the domain name here. Okay, this is a DNS server, and traffic manager looks is lies here mentioned in a virtual network, and client connects directly to the certain endpoint of the traffic manager. Wait a minute. Yeah, okay. So yeah, as you see, starting from here, the what do we call? Yeah, the request. Okay. So request goes to the requested DNS servers. Okay. Then it goes to the endpoint, which is provided by the traffic manager. This traffic manager then accesses the will leads you to the website which is deployed in the virtual machine. Actually, this is the external application. Oh, sorry, this is the web, and here lies the external web application, which is actually which is actually shown to the client. But before all these things occur, it looks for the health checks whether the uh, service is down or not. Okay, ensures whether the service is running properly, and then it exposes your application to the client. Okay, so this is how it works. HTTP request goes from the client browser to the DNS service, and the traffic manager looks into the checks the endpoint whether it is available or not. Available in the sense whether it is dead or not, and if then it checks again and does some matching, then your external application gets exposed to the client browser. So this is what about the Azure DNS Manager. So on Azure Firewall, okay, I guess this is the last service we have. So Azure Firewall is nothing but your actually I should have changed it to Azure Web Application Firewall, but yeah, fine. So Azure Firewall in general, it protects your VMs from the attacks launched on the network. Okay, and also we have a web application firewall which protects your web applications specifically. Okay, it protects your web application specifically from the web-based attacks like XSS, SQL injection, and if any other broken component vulnerabilities, etc. Okay. So coming back to Azure Firewall, we have three types: standard, premium, and basic. Okay. So looking into this is the standard firewall. So standard firewall enables threat intelligence and web attack categories. Okay, and also you mentioned the all the filtering rules, allows inbound and outbound access, etc. So all the threat intelligence reports gets directed to official Microsoft Center. Okay, and based on that you get a response whether you have suffered an attack or whether there was an attack attempt, etc. Okay, so it lies in the L3 and L7 layer 3 and layer 7 of the OSI layer. So this is about the Azure firewall, which is standard type. Okay, so we have Azure firewall premium. Okay, this what do we say, protects both the virtual machines and also provides advanced capabilities to protect your web applications too. Okay, so it can provide the TLS inspection, which is nothing but your certificate, and intrusion detection prevention systems (IDPS), and URL filtering. So, for example, there are some attackers who can tamper the URL and change the parameters, etc. And also other web categories, meaning again the SQL injection, XSS, XML injection, etc. Okay, as you see here, we can also filter the traffic between coming from on-premises to the Azure services. So Azure Firewall Basic. So this Azure Firewall Basic doesn't has threat intelligence, but not efficient as the previous tiers. Okay, just a basic you know service provision. Not so much advanced capabilities like premium and standard. But yeah, its main purpose is to prevent the attacks, right? So when it comes to preventing attacks, Azure Firewall Basic is actually good enough. Okay, so if you're a small startup, if you're a small startup who wants to deploy your application and also want to ensure the security of that web application, you can use Azure Firewall, Basic Firewall. So yeah, and if you have any problem in accessing the wait a minute. If you have any problem in accessing these or not knowing about the services, like what to use and when to use, you can go to this link. Okay, so this is the link. So see, if you want to connect everything from virtual machines to incoming VPN connections, deploy this, deploy that, etc. Okay, so this is you know very useful website when it comes to using network services in Azure. So yeah, and that's the end. Just follow me on LinkedIn if you like. I guess so far so good. If there are any doubts, first and foremost thing, if there are any doubts, please raise the questions. I know I went a little fast, I guess, and no one noticed me or mentioned that. So please, if you all have any doubts, just don't hesitate to ask. Okay, Uh, come on. I
If anyone has
guess,
a doubt, you can ask to Krishna. I guess everyone is clear with this session. Thank you, Krishna, for this wonderful session, and we
yeah,
add you. Thanks for your time.
yeah. Welcome,
So
Sabri.
everyone can leave the meet.
So yeah, people, thank you, thank you.